Before we dive into the content, let's do a bit of housekeeping. You can find additional resources, such as the PowerPoint for this recording, additional PowerPoints and additional recordings at aka.ms/teamsacademy. If you have any feedback for this session, please let us know. Go to aka.ms/teamscommunity, create a new community post and use the IT Pro training label. If you have any feedback for the features, how Teams behaves, please go to aka.ms/teamsfeedback and create a new idea or vote on an existing idea. Please also note that Teams and Office 365 evolve constantly. We add new features and functionality all the time. So stay up to date and follow us at aka.ms/teamsblog. This slide also indicates when the session was recorded, so that should give you an idea how much up to date the information is. After this session today, you will understand that direct routing allows you to connect your existing phone infrastructure to Microsoft Teams. You will also know that direct routing requires a certified session border controller, and you will understand the configuration for direct routing is documented in detail. We recommend that you watch the phone system introduction session and the network planning session before you consume this content so that you can get the most out of it. You can find these trainings at aka.ms/teamsacademy. So, what do we want to cover today? First, we want to talk about what is direct routing and when should you use it. We will talk about direct routing architecture and how the flows look like. We will talk about how you plan for direct routing, how you can configure direct routing, and finally, how to manage direct routing. So, direct routing, what is it and when should you use it? Let's just start very briefly with Enterprise Voice for the cloud. What you can see right now on the slide is Microsoft Teams and Office 365, our hub for teamwork. And we can add the phone system. It's an additional license or included in some of the licenses. We'll go into detail a little bit later, but phone system gives Microsoft Teams PBX capabilities. What we don't have at this point is any connectivity to the actual phone system. And there are two options. Either the Microsoft calling plans, where Microsoft provides you a phone number, or direct routing in Teams. In this session, we're going to concentrate only on direct routing. Just for the context, it's important to understand that if you want to give your users phone numbers and they should be able to call phone numbers, you need to have Microsoft Teams, the phone system, and then one of the two options, Microsoft calling plans or direct routing. Let's take a closer look at direct routing for Teams. In the lower right corner, you can see a user being connected to Office 365 using the phone system there. Over the internet, now the phone system is connected to a certified session border controller. This session border controller in turn could be connected to any third-party PBXs, any existing phone system that you have. It could be connected to an analog telephony adapter, so if you need to connect any analog phones. And then the session border controller is connected to a PSTN trunk. This could be a SIP trunk or a traditional PSTN trunk, but that leads to the PSTN network. And that means now if a user wants to place a call, we have here the connection via the phone system to the session border controller to the PSTN network. Don't worry, we will go into more detailed flows on signaling and media a little bit later in this session. Let's take a look at the customer example, how they are going to use direct routing and combining it with the Microsoft phone system. So in the example, Contoso is a multinational company and they have users in the USA, in the Netherlands and in Austria. Contoso is absolutely sold on the value of Teams and they want to make it the calling endpoint for the users. They want to get rid of all their old telephones, well, as much as possible at least, and enable users to send and receive their phone calls from the Teams clients. Additionally, in the Netherlands, Contoso has a call center. The call center users will, at least for the time being, remain on the existing PBX. So how should Contoso or how could they approach this scenario? So the users are located, said, in the USA, in Austria or the Netherlands. First, they need to look on where are calling plans available. Calling plans provided by Microsoft are only available in a selected number of countries. The USA, they have calling plans, Austria doesn't have, and the Netherlands do have calling plans. Then the special considerations, none for the USA or Austria, but there are special considerations for the Netherlands. They have this integration with their existing PBX for the call center users. So what are they going to do? So for the USA, they just go with calling plans, because calling plans provide them everything they need and they don't need to have any local equipment. In Austria, there are no calling plans, so that's where they are going to use direct routing. In the Netherlands, they want to do both. They are going to combine the phone system. So for all the users that are on Teams, they will get phone system, but they will also provide direct routing so that when a user on Teams calls a user who is still on the PBX, that this can be directly routed via the session border controller and doesn't need to leave their network. And this leads us directly into the benefits of direct routing. First, we have this interoperability with third-party systems. You have a PBX on premises, you still need to use it for some reasons, maybe just for a subset of users, no problem. This shouldn't block the rest of the users. If you have direct routing, you can route your Teams calls directly to this on-premise PBX and get sure that users from one system can call the other users. Also, you can leverage existing contracts with service providers. Let's say you just signed a new contract with a PSTN provider and they give you really good rates for national and international calling. Well, no reason that you get completely rid of them. You can still use them. Just get sure that you have the session border controller, you have direct routing, and that all the calls are terminated on Teams clients so that users can use Teams while they still benefit from your existing contract with the service provider. In Teams, if you have phone system, if you have telephony, every user will get a DID, every user will have a phone number that can be directly called. You can use direct routing in any country where calling plans are not available. If Office 365, if Teams is available, so is direct routing. As shown in the example before, direct routing can be combined with calling plans. So you can choose if a particular call should go via calling plans or via direct routing. And there's less hardware footprint if you look to Skype for Business. In Skype for Business, we had a similar solution. It was called Cloud Connector Edition, but it required you to run virtual machines on some Windows Server hardware. And here, all you need to have on premises is a session border controller. And there are also options how partners can host these session border controllers on your behalf. So ultimately, you can do it without any hardware that you need to run or maintain yourself. An important additional consideration for direct routing are service numbers. Service numbers are special phone numbers that are able to handle a high concurrency of calls, which is required in scenarios like call queues, auto-attendant, and dial-in conferencing. Please note that today, service numbers need to be provided by Microsoft. So you can get these phone numbers from us. You cannot leverage your own phone numbers for service numbers. What you can do, however, is you can consider porting your own number to Microsoft and then use this own number for as a service number. For call queues and auto-attendant, we expect to support your own numbers via direct routing soon, so please follow our blog for the latest announcements. Another important consideration is if you have Skype for Business hybrid, so if you have some of your users on-prem, some of them online. If a user wants to use, or if you want that user to use direct routing in Teams, then the user must be homed in Skype for Business online. Emergency calling works a little bit differently from traditional telephony. In traditional telephony, you have a phone line and it goes to a certain location. So if an emergency call comes from a certain phone number, you know what location it came from. In Teams, because users can just roam around, that doesn't work exactly that way. Still, the location information is based on the phone provider. So the phone provider gives you the phone number and they have location information of the user. Since Teams users might be roaming around, you need to acknowledge and provide notice to users that Teams might not know the actual location of the caller. That also, if the user's device has no power, no calls will be possible. So if the laptop runs out of power, they can't use it to make an emergency call. Emergency calls should never be made if the user is outside of their office country or region. So if I'm located in Austria, and that's where I have my phone number, but then I travel to another country, I should never use Teams to do any emergency calling. All these details you can find at aka.ms/emergency-calling. So now that we know why direct routing is great and why we want it, let's take a look at the flows. Let's start with signaling. First, let me introduce the diagram. At the top, you see the Office 365 network, the global network that is run by Microsoft to deliver great quality for Office 365 services to all of our customers. Then we have the internet. And finally, on the bottom, we have the corporate network, your company network. Users can either connect from the internet, so they're outside of your corporate network, or from your corporate network to Office 365. If we have a user from outside the corporate network, they will have the signaling sent directly to a component in Office 365 that's called the call controller. And signaling is really all this information of, well, I'm online, I want to initiate a call with this or that person, this is how I can be reached, and so on. From a user on the corporate network, flow looks the same. From this user, the signaling travels to the call controller. Then within our Office 365 cloud, well, obviously there are a few more components involved, but there is the SIP proxy. The call controller communicates with the SIP proxy, and now the SIP proxy can exchange signaling with the session border controller in SIP, the session initiation protocol, a protocol that is used a lot in telephony. The session border controller, think of it as a call router. It sits on your corporate network, and now you have this connection where if a user wants to place a call or needs to receive a call, via the signaling from the call controller over the SIP proxy to the certified SBC, we have this connection established. And then the SBC can communicate with the PSTN next top. So this might be your phone system that you have on your premises, or it might be a PSTN trunk coming into your environment. While signaling always looks the same, media is a little bit more complicated. So we're going to use this slide to introduce these two new components, the media processor and the transport relay, and then talk about different scenarios in the following slides. So the first component we want to talk about is the media processor. The media processor transcodes media from one codec to another. So the Teams client uses some specific Teams codecs that the session border controller might not understand. In that case, the media processor can transcode the media for the session border controller to understand it. The media processors are located in our data centers in North America, in Europe, in APAC, and in Japan. The transport relay is a relay that relays real-time media if a direct connection is not possible. However, they are not doing any additional activities with the media. So it is really just a relay. So if one endpoint wants to talk to another endpoint and they want to send media, but they can't because there's a firewall in between them, they will just send the media to the transport relay, and then the transport relay will relay it. The transport relays are deployed worldwide and not only in the main data centers. Let's look at our first example, media without any media bypass. So we have here our outside user, and all this traffic will always be sent, if there's no media bypass, to the media processor. The media flows first, a very short leg over the public internet, until it's routed to the global Office 365 network. The Office 365 global network has peering points all over the world, so this leg should be really, really short where you are on the public open internet. Then, on the Office 365 network, you will have great quality because it's optimized for Teams traffic and real-time communication. For internal users, this is exactly the same, well, except for the fact that they spent the first leg on the corporate network. Then the media processor transcodes the call, And the media is sent over the Office 365 network, over a short leg on the internet, to the corporate network, to the certified session border controller. From there, it goes to the PSTN, and now we have our media flow established for a non-media bypass call. For media bypass, the exact scenario of media flow depends on where your users are located and how you have configured your environment. In this first scenario, we're looking at internal media bypass. So, the internal user on your internal network wants to do a call. So they establish a connection directly to the certified session border controller, bypassing the media processor. So here, no traffic is sent to Office 365, everything stays within your network. This, however, requires the user to be able to connect directly to the external IP address of the SBC, which means you need to allow this kind of hairpin on your firewall where the user, well, the client, needs to be able to send traffic outside so it then can come back in again to the public IP of the session border controller. If, for whatever reason, this hairpin is blocked, the traffic needs to flow via transport relay in Office 365. And we're going to look at that in one of the next slides. The benefit of this scenario is that, as you can see, the traffic doesn't need to go to Office 365. It stays on your network, which is most likely a much more direct route from the user to the session border controller, which means you can eliminate some latency. Also, because everything is on the corporate network, you can 100% manage this traffic. You don't need to rely on the internet and the quality that the internet might provide to your users. Now let's look at an external media bypass scenario directly. Now the user that we're looking at is outside the corporate network. The user will try to connect directly to the certified session border controller and send the media. This traffic will flow completely over the public internet until it hits your corporate network, and then it will talk to the session border controller. So in this scenario, you will not go via the Office 365 network, and you cannot benefit of the quality that the Office 365 network can provide to you. This, however, means also that on the SBC side, the firewall needs to be configured to allow this incoming traffic from any media port, from any IP to the SBC. Well, because your users could be sitting anywhere in the world on the internet, so any IP, and the traffic could come from any source IP, because there might be any netting between the user and the SBC that will change the source address where the traffic is coming from, so the client traffic might really have any IP or any port. So, what happens if your external user can, for whatever reason, not connect directly to the SBC? Maybe because you decided to not open the required ports and IPs on the external firewall. Well, in that case, the traffic will just flow via the transport relay. So there's no additional configuration or setting in the client required. That's just the logic of the client that it will try to go the most direct path. But if the most direct path doesn't work, well, it goes via the relay. And in this case, again, there will be only a very short leg from the user on the internet until the network provider on the internet can route the traffic to Microsoft to the Office 365 network. The transport relay, again, it only relays the traffic. It doesn't do anything to the media, it doesn't do any transcoding or anything. It really just relays the traffic, and the transport relays, they are deployed worldwide. So there's a very good chance that there's a transport relay quite close to the user. Then, from the transport relay, it flows over the Microsoft 365 network, over a very short leg on the internet, to the certified session border controller. And on the session border controller, you need to open this connection to the transport relay, but only to very specific ports and IPs from Office 365 only, and they are well documented. And from there, the media can be sent to the PSTN next hop. So let's summarize the media bypass. First, the media processor. The media processor, well, processes media and will always use if media bypass is not configured for users. So all the calls will have to travel via the media processor. If a user is enabled for media bypass, then the media processor will never be used. The media processors are deployed in the Microsoft main data centers only. On the other hand, the transport relays, which function as, well, relays. If media bypass is enabled, the call might travel via the transport relay, depending if the user can connect directly to the SBC or not. The transport relays are deployed all over the world, much closer to the end users and to your data centers. If users can send traffic directly from their client to the SBC, the traffic will never use the Office 365 network. Traffic between your endpoints and the transport relay will fully benefit of the Office 365 network. So what are the recommendations for media bypass for your environment? Well, it's important to note that the actual mileage will depend on multiple factors, like the location of your endpoints and the SBCs, and the proximity of the next transport relay. The rule of thumb for internal endpoints is that you want them to allow directly to the SBC. That will allow you to keep all the traffic on your internal network, and you avoid the detour over the internet and the Office 365 network. So you can fully manage the traffic, everything is on your network only. The rule of thumb for external endpoints is that you want to block the direct connection between your external endpoints and your SBC. This way, you can force the traffic over the Office 365 network and minimize the public internet. Obviously, there are exceptions. So for internal endpoints, if you have very weak connections between branch offices and your main data center, maybe it would be better to force the traffic over the Office 365 network instead of having it internally. Also for external endpoints, there might be situations where you could prefer endpoints connecting directly for the SBC. Maybe because there is no close transport relay, or maybe because they are so close to the SBC anyway. Now, let's talk about voice routing. Dial plans are how about users can dial phone numbers. So sometimes the PSTN network might expect a different phone number format than the user wants to dial. And actually this will be the case in most cases. The PSTN network, or the phone system, expects all numbers normalized to an E164 format. That means the phone number would look like plus, international dialing code, national dialing code, and then the phone number. So for a US number, this would be, for example, +1 555 123 456. Obviously, users prefer not to call these long numbers. They prefer to not dial the international prefix and not dial the plus, so they might just dial 555 123 456. So there are dial plans built in that will recognize what the user is trying to dial and then normalize this phone number to E164. These built-in rules are for the most common rules, but you can also build custom rules that can allow short digit calling. So it would allow, for example, this user not to even dial the area code 555, but just to go to 123 456. And because of what is configured for this specific user, the system would know, oh, this user is in an area code that requires 555 and would prefix that to the phone number along with the +1. You could also use custom dial plans to allow extension dialing. So for example, the user is used to dial his colleague with just the extension 456, and then the system would know, oh, these numbers need to be normalized to +1 555 123 456. Teams has built-in rules for the most common normalization rules, which should be working for most of your users. However, if you want to build, if you want to make it more comfortable, then you can also create your own normalization rules and dial plans. In this training, we will not go into further detail, but we plan to release a training that will. So once the user has dialed the number and the number has been normalized, how will Teams deal with this number and decide how to route it? In this example, a user from Germany makes a call to +1 800 642 7676. So the first thing that the system will check, is there a voice routing policy existing for this user? If not, then it means this user can't use direct routing and will have to fall back to calling plan. If there's no calling plan for the user, that means, well, the user has neither direct routing nor a calling plan, so the call will fail and the user can't place the call. If there is a calling plan assigned to the user, then the system will check, is this a domestic or international calling plan? If it's domestic only, this call will fall again. Why? Because this is a German user and the call to +1 is a call to the US. So this would be an international call for this user and this call will fail. If the user has an international calling plan, then this call will flow via the Microsoft calling plan. But if the user has actually a voice routing policy existing, means this user is a user for direct routing. Within this voice routing policy, there are different PSTN usages. They are evaluated in order, and each of these usages can have multiple routes. So now the system is looking first, does the user have a voice routing policy and what are the PSTN usages? If there's no match, it means that this user doesn't have any voice routing policy that allows him to dial this phone number. Then we go back to the check if the user has a calling plan, and then the call will either fail if there is no calling plan or if there's just a domestic one, or the call will succeed via Microsoft calling plan if there's an international calling plan. However, if in the voice routing policy there's at least one route that matches the dial pattern, then the call will be tried via the SBCs that are in the route. So each route can have multiple SBCs for load distribution and failover reasons. If this succeeds, then the call will be placed via direct routing. If all of the SBCs are not functional, because they are down for maintenance, then the call will fail. So how can you plan for direct routing? Deploying direct routing requires a few planning steps. First of all, you need to figure out if you want to deploy the SBC yourself, if you want to host it in your environment, or if you want to work with some partner who hosts the SBC on your behalf. Next, you need to figure out what licenses you need and get these licenses and assign them. Then you need to choose the session border controller, which model are you going to use. After that, you need to decide if and how you want to configure media bypass. Then you need to configure your FQDNs and certificates. You need to configure your firewall. You need to decide how many SBCs you want to have and how you configure them. And finally, if you're a hoster, you need to figure out how you want to host the SBCs. Self-deployed versus hosted SBC. Direct routing allows for a hosted SBC model. That means a partner can offer an SBC to multiple customers. They just need a single certificate per SBC, need a single IP address for SBC. So this is a solution that scales very well for multiple customers. And there are a lot of benefits for the customer, but also some disadvantages. Basically, the benefits is if you deploy your SBC yourself, you have full control over it. You can do whatever configuration you need, whenever you need, connect to your existing PBX, but you are also fully responsible for this SBC. So you need to have a location to host it, you need to run updates, you need to maintain it, you need to purchase it, etc. So from a cost perspective, it might be beneficial to have a partner who hosts it for you. So if you have a partner hosting the SBC for you, you don't have any environment, any equipment at all on premises. All your PSTN services come from either Office 365 or this partner hosted SBC. They purchase the SBC, they maintain it, they configure it, which reduces a little bit the control that you have and makes the support model a little bit more complex. Because now, if there's any quality issue or any connectivity issue, you don't have visibility yourself to all the components, but need to work with the partner in addition to working with Microsoft. Please note that when you're working with the partner, that there's currently no certification program from Microsoft. So any partner can just offer this service to you, but Microsoft is not requiring to pass any tests or do any quality checks. They can just move forward and do that. So be sure that you understand very well the cost structure, how much they are going to charge you for this service, the support process, how you can escalate any problems and how they are going to work together with Microsoft, the partner architecture, so how they're using the SBC, if they're using an SBC that is fully qualified by Microsoft, and do some tests if the quality meets your expectations. In terms of licensing, all your users will require a Teams license. Then, if they want to use direct routing, they need to have a license for phone systems. Phone system is already included in E5, but it's also available as an add-on on E1, E3, and E4. Optional, you can use a calling plan. It's also an add-on to phone system if you want to provide users both abilities to do calling via direct routing and via calling plan. Finally, also optional, audio conferencing. This is required if you want to add additional PSTN numbers to an existing group call. For direct routing, you need to use a certified session border controller. The session border controller is that component that connects the Teams call to the PSTN next hop. The PSTN next hop can be a third-party telephony system or telephony trunks. The certification process uses a third-party lab where we validate all the required functionality of the SBCs. And we also test in a pre-production environment all the SBCs daily to get sure that if we make any changes to the Teams service, that the SBCs can still work completely with direct routing. Also, there's a joint support process with the SBC vendors. So if you run into any issues and you open a support call, the support of the SBC vendor and Microsoft will work together. Please also look at this link for a list of the supported SBCs. And since we're working with the SBC vendors on a regular basis, there might be also new SBCs vendors being added or new models. So you should visit that page from time to time to stay up to date with the latest list of certified SBCs. When planning for media bypass, it's important to note that not all endpoints are supported. If you have a 3-pip phone, these old Skype for Business phones that also work against Teams, well, they don't support media bypass, and neither does Teams in the browser. We are working on these scenarios to enable them in the future, or at least provide fallbacks within the product. But at the moment, as of today, these endpoints, they will just try to do media bypass, but because they can't, the calls will fail, and the users might get an ugly error message that tells them something went wrong. The workaround is that you can create additional non-bypass voice routes for users on these endpoints. So if you, for example, have an office where you know, oh, in this office we have deployed 3-pip phones and you expect users to use them from there, well, then you can just create for these users in this office a special voice route that doesn't do media bypass, and all your other users can still benefit from media bypass. If you want to do that, you need to use a different FQDN and signaling port for the same SBC, but you can use the same media ports. A list of SBCs that support media bypass can be found at the link listed here. Microsoft communicates to the SBC via the FQDN, so you need to have a fully qualified domain name so that Microsoft can locate and find your SBC. It's important that the domain of this FQDN is registered with Microsoft. That means you cannot use an onmicrosoft.com domain. It's not supported for SBC names. You need to have a vanity domain. So for example, if you use contoso.com as the DNS name that's registered in Office 365 tenant, then you can use, for example, the following names: sbc1.contoso.com, US sbcs15.contoso.com, whatever you want.contoso.com. What you cannot do is adding another subdomain. You could not do sbc1.europe.contoso.com. Well, you can if you register the domain name europecontoso.com in domains first. Registering a domain is not very difficult, and we don't have all the details here. If you need to have the details, just go to ak.ms/add-domain. But it's basically in the Office 365 administration portal. As a global administrator, you go to the domain section and then you add a domain. Then it will ask you to create a specific domain record, which basically proves that you are the owner of the domain. And because you can make this change to the domain record, we know that you own it and can verify you. Once you have added the domain, now you can use that domain for your SBC names. The certificate is used to validate the identity of the trusted SBC. So you have your FQDN of the SBC, and there's a certificate that proves that this is really the server it's supposed to be. This certificate is signed by a trusted certification authority, so only you, because you have the certificate, can own this domain name, and only you have the server that runs in that domain, so we can trust this SBC. If you have just a single SBC, well, then you just put the name of the SBC in the subject name and you're good to go. However, if you have multiple SBCs, there are different scenarios how you can design your certificates. And depending if you want to minimize the certification cost or if you want to maximize the security, you have different options. So for the sake of the example, you have 4 different gateway SBCs. You call them gateway1.contoso.com, gateway 2, gateway 3, gateway 4.contoso.com. In the scenario where you want to minimize the certification cost, you put one of these gateway names in the subject name, and then in the subject alternate name, you just put *.contoso.com. You're using a wildcard certificate. And now this certificate can be used on any of the other SBCs that you're using, because all of them are matching this certificate, this wildcard certificate. They have some dedicated part, but then there's .contoso.com. Or you could use a single certificate with multiple subject alternate names. So in this example, the subject name is gateway1.contoso.com, and then all the individual servers are also listed in a subject alternate name. Please note that if you ever decide now I want to have gateway5.contoso.com, you need to change your certificate or get a new certificate. So these more secure options also reduce the flexibility that you have. Then the maximum security scenario, you have one certificate per server. You dedicate this one certificate for all your servers. So the first SBC gets gateway1.contoso.com, the second one gets a dedicated certificate, gateway2.contoso.com, and now you have multiple certificates that you're going to use. You can find a list of all the supported certificate authorities with the link shown on this slide. When it comes to IP ranges and ports that you need to allow on your firewall, please note that the SBC requirements are different from client requirements. So clients will need to talk to different FQDNs and use different ports. What we can see here on the slide are just the requirements for the SBC. The SBC itself can have a public IP or can be behind the net. For the firewall configuration, 2 things are important. One is the SIP signaling that happens between the SBC and the SIP proxy, the SIP proxy being this component in Office 365 that the SBC can talk to via SIP. The ports on the SIP proxy side are pre-configured by Microsoft. You can see them here on the slides. The SBC ports, this is something that you need to configure on the SBC, and the different SBC vendors provide guidance on what you should configure. The IP addresses, well, the FQDN and IP addresses for the SIP proxies, you can see them also here on this slide. And please note that no matter in which location you are, the SBC needs to be able to talk to all of these locations. In case that we have ever an outage and it, for example, cannot talk to a Europe location, then it will fall back to the Americas or Asia. For the media ports, same principle. You can see here the ports that, in this case, the media processor needs to talk to the SBC, and the SBC will talk to the media processor. The SBC ports are defined on the SBC, And for the media processor ports, you can see the ports here on this slide. Also, the media processors are in the IP range that you can see here on this slide. So from an from a port perspective, IP perspective, these ports need only to be open to this one range of IP addresses. So you can get sure that your SBC will talk only to these trusted networks on these specified ports. And we highly recommend, for security reasons, to configure your firewall that the SBC can indeed only talk to these ports and IP addresses. If you want to enable media bypass, you need to open a few additional IP ranges and ports. And I want to stress, these are additional. So what we have just discussed on the last slide, you still need, but you will need additional IP ranges and ports. Please note that the signaling doesn't change. As we've learned earlier in the session, the signaling always goes to the call controller, no matter if you're doing media bypass or not. However, from a media perspective, now the SBC needs to be able to talk to the transport relay. For internal media bypass, if you have an internal user wanting to talk to the SBC, well, you need to allow this hairpin on your firewall so that they can talk to the external IP address of the SBC. For the media ports where the transport relay and the SBC need to communicate, you can find here in the table the required IP ranges and ports. Again, this is additionally to what you have already configured on the slide before. You can leverage multiple SBCs to provide low distribution, high availability, and disaster recovery. If you have multiple SBCs in the same location, you can just group them within a single voice route, and the load will be distributed between them. And if you need to take down one of the SBCs for maintenance, or if you lose one of the SBCs for whatever reason, the load will be just distributed to the others, assuming that they can handle the full load. Depending on the SBC vendor, you can also cluster multiple SBCs, and they will appear to teams, just like a single SBC. If you do it like this, then the load will be equally distributed between these SBCs. Sometimes there might be situations where you want to prefer a specific set of SBCs and just use others for backup. You can do that by configuring multiple voice routes and having priorities assigned to these voice routes. And if no SBC is available to take a call with the highest priority, the next voice route with the next highest priority will be used. And this way you can fail over to other SBCs if you need to. Disaster recovery, this is very similar or uses the same concept, but here we are thinking more of a scenario where, let's say, you lose all your SBCs in the US, but you want that your most important users can still place calls by using the SBCs that you have placed in Europe. So you can configure voice routes that are only assigned to the users that should be able to do these calls. So again, you lose all the SBCs in the US, but for the users who have these routes assigned, they can still use the SBCs in Europe and place their calls. This slide is about how SBCs can be used for multiple tenants. Most likely, this slide is only relevant for partners who want to offer the hosting of SBCs. There are two parts to the configuration. There's the hoster side and the customer side. As a hoster, first, obviously, you need to deploy and configure SBCs. You then need to register the domain name in the carrier tenant. The assumption here is the example that the partner has the domain contoso.com, and now they register a new domain, customer.contoso.com, and they will use this domain to home all of the SBC names. Next, they request a wildcard certificate, *.customer.contoso.com, and this will be used for all the SBCs they're using and for all the customers accessing this SBC. As you can see, one certificate will be sufficient to support any number of customers on any number of SBCs. Now per customer, they need to register a subdomain for every customer. So in the Office 365 portal, they need to register these new domains and need to say, well, I have a new customer. It's called customer1.customer.contoso.com. The certificate will be valid for this domain because it's a wildcard certificate. Obviously, you could also use the customer name there, litwerinc.customer.contoso.com, if that's any easier for you. Then you will use this FQDN of the subdomain for the SBC. So now the SBC gets the FQDN customer1.contoso.com. So if you have multiple customers, you will have as many FQDNs pointing to the very same SBC. And the certificate, being a wildcard certificate, will be able to verify the identity of all of them. On the customer side, you need to register and activate the subdomain, the customer tenant, customer1.customer.contoso.com, and then you need to go and configure your trunk from the hoster to your tenant. Let's look at an example for a partner hosting an SBC for multiple customers. We have here a datum. A datum has an SBC. A datum wants to use this SBC with 3 different customers: Woodgroove Bank, Contoso, and AdventureWorks. The default domain of a datum is adatum.biz. They now register an additional domain called customers.adatum.biz. This will be used to provision the customers with access to the SBC. They also get a certificate, *customers.adatum.biz, so that they can support all the different FQDNs that they're going to use. For Woodgroove Bank, they're going to use sbc1.customer.adatum.biz. sbc2.customers.adatum.biz will be used for Contoso, and finally sbc3.customer.adatum.biz will be used for AdventureWorks. And as you can see, now a datum can serve 3 different customers with a single SBC with a single certificate. Obviously, they can add more customers as they want. And obviously, they should probably not only have a single SBC, because if this one single SBC goes down, well, then all of these customers couldn't do their calls anymore. So a datum can do the same and add additional SBCs, cluster these SBCs, do whatever they need to provide the right service to their customers. Having completed all the planning steps, we can now go into the configuration for direct routing. The SBC configuration includes a number of steps. You need to assign the SBC a license, you need to configure the LAN and WAN IP interfaces, you need to configure the certificate, you need to configure signaling and media ports, SIP options, and SRTP settings. You need to configure the connection to PSTN Next Top. As part of this training, we will not go into any of these details because they are different per SBC vendor. However, on our website, you can find the links to the SBC vendors where they provide the guidance. Please carefully follow the guidance, as it will help you to configure your SBC correctly and will help you to avoid any problems or issues. You can find a link on this slide. So now your SBC is configured. Now you need to pair the SBC with your environment. There's a very simple PowerShell commandlet that you can run, or that you need to run. It's the new CsOnlinePSTNGateway, and you provide an FQDN, 6 signaling port is configured on your SBC, maximum concurrent sessions, and a number of other attributes. And we'll go into these other attributes over the next slides. You can run the new or set CsOnlinePSTNGateway with the following parameters. The SIP signaling port defines the SIP signaling port on the SBC. So whatever you configure on the SBC as a port to listen for signaling, this is what you need to configure here as well. The enabled parameter allows you to put the gateway actually in a disabled state where no new calls would be put to the SBC. However, incoming calls will still be accepted. So if you want to drain, for example, your SBC, you want existing calls to continue, but no new calls being placed to the SBC, you can set enable to false, and no Teams users will put new calls to the SBC. And once you don't have any calls on the SBC, you can turn it off or update it or do whatever you need to do. Since this is valid only to the Teams side, you need to get sure whatever your next hop on the PSTN side is also is aware that you want to drain the SBC and doesn't send any new calls to the SBC. The forward PII is the P asserted identity, and that can be used for billing purposes. The default value, however, is false. The forward call history is history information about call forwarding, and can also be used for billing purposes. The default value is also false. SIP options enabled allows our Office 365 Cloud and the SBC to exchange SIP option messages. And these messages are used to determine if an SBC is available or not. If an SBC is not available, then we don't need to send any calls there, and then we will not see any missed calls. We highly recommend to turn on SIP options, and the default for this value is true. The maximum concurrent sessions is used for alerting systems. So when the value is set, an alerting system will generate an alert to the tenant administrator if the number of concurrent sessions is 90% or higher than this value. So if you know how many sessions you can support, you should really use that in order to build a good monitoring system. The enable fast failover timer will fail over calls if the gateway the SBC doesn't respond in a timely manner. So this is usually a great thing because, Teams tries to send a call to a user, the SBC doesn't respond, so it fails over to the next SBC. However, we've seen cases with slow networks where the SBC was not offline, where it was in fact working, but didn't respond in time, and then it was a false positive to mark it as offline. If you are in such a situation, then you should disable the enable fast failover time. And then finally, media bypass. You need to configure this if you want to configure media bypass. For the user provisioning, we are here considering these two cases, one where you have only direct routing for a user configured, or where you have direct routing and calling plan configured for a user. In both cases, you will need to have a Skype for Business Online Plan 2 license, you will have to have a Microsoft Phone System license and a Microsoft Teams license. Additionally, for the calling plan, you need to have the calling plan license. The phone number is configured depending on what system, what option you're using. If you're using direct routing only, the phone number is configured in the on-premises or Azure Active Directory. If you're using Microsoft Calling Plan with direct routing, then the phone number comes from either Microsoft, or you need to port your phone number over to Microsoft, but it is hosted by Microsoft. The routing, in direct routing only, the administrator configures the route and only these routes are evaluated. If no route is found, then calls will drop. If you have mixed the calling plan and direct routing, then first the routes configured by the administrator are evaluated if there is a direct route to be used by users. If not, if there is no direct route, if there's no route configured, then we will fall back to using the calling plan. And this is something that we have seen earlier in the session on the list on the number routing. Let's look at a simple configuration with a single SBC. So this is our sbc1.contoso.com. So that Teams is aware of it, we run the new CsOnlinePSTNGateway command and create a new gateway. We provide the FQDN, sbc1.contoso.com, and we provide the SIP signaling port that's configured on the SBC, which is in our example 5068. And we're saying enabled true, so the gateway, the SBC, is now willing to accept calls. In order to configure who will be using this gateway, we are creating a new set CsOnlinePSTN usage, identity is global, and we add the usage unrestricted to it. Now we create a voice route. The voice route, new CsOnline voice route, the identity is also unrestricted, and the number pattern is .*, so we really accept just everything. The online PSTN gateway in this voice route is the sbc1.contoso.com the priority is 1, so it has the highest priority, and the online PSTN usage is unrestricted for it. And now we need to get sure to create a voice routing policy and assign it to a user. So we create this new CsOnline voice routing policy called unrestricted, and it can use the usage online PSTN usage unrestricted. Now we grant this CsOnline voice routing policy to a specific user. The identity is Spencer Lowe, and the policy name is unrestricted. So now this user has a routing policy that includes an online PSTN usage. This online PSTN usage includes the route, and this route includes the gateway, so this user can use the gateway for any call. Here is a more advanced configuration. So we have these two gateways in one location. We add both of them with the new CsOnlinePSTNGateway, provide the FQDN, the signaling port, and enable them. We create a PSTN usage, set PSTN usage to our global identity, and the usage is US and Canada. So obviously these two gateways are in Canada. We create voice routes. So any numbers for phone numbers +1425 or +1206 are assigned to this voice route with the highest priority, priority 1. So you can see here, new CsOnline voice route, identity Redmond 1, the number pattern, you can see here the regular expression for the two prefixes. The online PSTN gateway list is SBC1 and SBC2, priority is 1, and the PSTN usage is US and Canada. Now we add two more gateways, SBC3 and SBC4, signaling ports enabled. They are getting the same number ranges for the route, but they have a lower priority. That means if now someone places a phone call to a number that starts with +1425 or +1206, they would be sent to SBC1 and SBC2. Unless SBC1 or SBC2 are busy or not available, then they would be sent to SBC3 or SBC4. Now we create another set of gateways, SBC5 and SBC6. And we create a pattern for all other calls. So a new CsOnline voice route, the identity is just all other +1 calls, the number pattern is +1 and then any 10 digits. We're adding the online PSTN gateways SBC5 and SBC6 and add it to the online PSTN usage US and Canada. That means in this case now, if a user calls any number that's not starting with +1425 or +1206, it will go to the gateways 5 and 6. If they are putting a call to the numbers +1425 or something starting with +1206, it would be going first to SBC 1 and 2. If they are not available, it would be going to SBC 3 and 4, and only after it would be going to SBC 5 and SBC 6. All of that will be now put into the CsOnline voice routing policy. It's called US only because all of these are just US and actually, by the way, Canada numbers. We are adding the online PSTS usage US and Canada so they can use all these routes. And then we grant this to the user Spencer Lowe, and we give it the policy, the name US only. Now, let's look how we can manage direct routing. Let's use this simplified view to understand how these different components can be supported and who is involved. So if we're looking here between the user and the SBC, then you need to look into the call quality dashboard. It's a tool in the Teams admin portal that provides you an aggregated view on the quality of all your calls in your environment. And you have the call analytics where you can look into individual calls. On the SBC, you also have SBC logs. And if you're interested to troubleshoot the SIP traffic, the signaling between the SBC and Teams, then this will be the best place to look into these logs because they are very easily accessible on the SBC directly. If you have your SBC connected to a PBX, then you might want to look at the PBX logs in case you have any difficulties on calls between Teams users and PBX users. And then finally, if you have troubles on calls to your PSTN, you might want to look into the connection to the PSTN and see if any problem is there. On this slide, we have collected a number of common issues that we have seen in configurations with SBCs. The best way to see the symptoms is to look into the SIP logs on your SBC. Starting with the first one, if you see the missing, if there's no 200 OK for the option message being sent out, usually this indicates that there is a missing root certificate chain or that there's a firewall misconfiguration. If you see the error failed to verify peer certificate, that usually indicates that the Baltimore root certificate has not been installed. If you see the 403 forbidden on options, provided trunk FQDN is not allowed, it means that the contact header on your SBC is not defined. So when your SBC sends messages to Office 365, it most likely sends just the IP address, but not the FQDN. Since Teams, Office 365, is expecting the FQDN, it will send back this error message. Also, if there's a typo in the FQDN, you will see the same error message. If you see transfers of calls failing and you see a 603 decline from the SBC, it means that refer support has not been enabled on the FTC. If a call connects, but you don't hear any audio and the call connects shortly after, most of the time this indicates that there is a net traversal issue. So you have most likely configured your SBC behind network address translation, but you haven't configured the SBC to be aware of it. You need to change this configuration so that the SBC is aware of its public IP address and can advertise the public IP address to Office 365. If you see all outbound callers as anonymous, so a Teams user calls a cell phone user, and on the cell phone the call ID is not shown, it just shows anonymous, check if you have enabled forward PII. If you have enabled forward PII, you need to do a couple of additional settings on the SBC so that calls are not anonymized when they are being sent out. If you're seeing a 404 not found for incoming calls to the Teams environment, that means that most likely the user phone number is not configured correctly in Office 365. So someone dialed a number, the SBC thinks it needs to send it to Office 365, but Office 365 is not aware of the number, and that's why it doesn't accept the call and sends back the 404. If you see outbound calls failing, it might be that your dial plan includes some regular expressions that are invalid. And even if the particular rule is not selected, was not used for that call, just having an invalid rule in a regular expression can make it break and can make outbound calls fail. Now, let's look how we can manage direct routing. Now, after completing this session, you know direct routing allows you to connect your existing phone infrastructure to Microsoft Teams. You will require a certified session border controller, and the configuration for direct routing is documented in detail. Here are a few additional resources. So for more PowerPoints, including this PowerPoint, and more recordings, go to aka.ms/Teams Academy. If you have any feedback on this session specifically, go to our community aka.ms/Teams community, create a new post, and use the IT Pro training label. If you have any feedback on the features, if you like how direct routing is working, or maybe you don't like it and you have some ideas what should be added, please go to aka.ms/Teams feedback, create a new idea, or vote on existing ideas. Again, here the point to aka.ms/Teams blog to stay up to date with the upcoming features of Teams and Office 365. This slide also includes the date on when the session was recorded, and that should give you an idea how much up to date the information is. This concludes today's session. Thanks a lot for your attendance and see you next time.